Hello guys, welcome to my ATA channel, and in this tutorial we'll learn about numpy library. So let's start. Universal functions. I'm going to create an array and see element wise array functions. So if you give square root, then every element in the array gets a square root. So see, each and every element got a square root over it. So square root of 1 is 1, square root of 2 is 1.4, 1.7, 2, 2.2, 2.4, and 2.6, 2.82. Square root of 9 is 3. So that's actually good. And exponential. So e power 0 is 1, e power 1 is you know that e value is 2.71 something. So yeah, now I'm going to create randomly array of 8 elements, x comma y. So let me look into the x and y values. Okay, so np dot maximum will help you in finding the maximum elements of x and y. If you you're giving x comma y, right? So it'll compare these two element wise and it'll return the maximum value from that. So if you look these two, if you compare the first elements of these both arrays, then the output should be 1.2467594 because that's the maximum. So let's see you got the output as so. Similarly with every element, and minimum should print minus 0.78 because you're comparing both and you're returning the minimum value. Let's check that as well. See, this is the minimum value, so this gets as the output of the first element. Similarly, and so sometimes you can get multiple arrays as well, so there's some that's you can see that actually I can explain here. So first of all, let me create an array. This is actually an array, it's nothing special, random array with 7 elements, and I'm just multiplying all the 7 elements with 5. In order to make it somewhat bigger, I'm just multiplying with 5. That's it. And see, fraction comma integer part. See, the np dot mod, this will return multiple arrays. So the first one would be the fractional part, and the second one would be, let me just let us check what is this array. Okay, this is the array. So you can see minus 2 is the integer part, and this 0.4599, this is the fractional part. So if you give np dot mod f, then it will just splits this into integer and fractional part, and the fraction will be going to the fractional one and the integer part will be going to the integer part. So if you run this and if you look at the fractional part, see, only you'll be having the fractional part 0. minus 0.4599 minus 0.0482 minus 0.05. You understand it, right? And the integer part, that would give only the integer values, minus 2, minus 3, minus 0, minus 7, 5, minus 2, minus 1. That's it. And yeah, it's again, this is our array, and as I told you, if you apply square root for that, see, the reason for here is you have negative values here. So negative square root of the negative value will result in, it's an imaginary error, so here we get nan. This is positive. I got, so we got positive value over here. It's fine actually. np dot square root of array comma, in the again you have these both are actually same, but look, by doing this the main array will also get converted. Here I did np dot square root of array, and when I return array again, then you'll get the original value as it is. But now I've given array comma array, that means the array gets stored, the values, these values will be stored in the actual array. So again the actual array will also return the same thing. If you could see here, see, look at the output, see, both are same. Now the array is completely changed to this. So that's the use of this np dot arrange. So this means it starts from minus 5 and it's end up to 4.99 because, and it increases with a step of 0.01. That means minus 5 minus 4.99 minus 4.98. You got it, right? So this is the initial value, it is the ending value, and this is by which step it should increase. Okay, that's points, and I'm going to, the mesh grid is going to create points so that the axis would be, here they are decreasing in this manner. I mean, you're getting minus 5 to minus 4.99 in this fashion, but whereas in y's by using mesh grid, they'll they're going to change in the column wise. Here they are changing in row wise, and here you can see -5, -4.9, and ultimately got 4. That's the difference. And see, you could see that x's and y's both are of same length, and I'm going to convert the square root of x square plus y square. And I can actually remember a circle, right? This is the equation for a circle. Z square equals to x square plus y square is something same as x square plus y square equals to r square. So that means center at origin and having radius r. So this is the z value, and if you want to see that circle, I can we can use matplotlib, and I'm just importing matplotlib now, and plt.im show z here is the our circle value, and color map I'm going to get the image in gray color. So let me just print this. Yeah, see, you could see that circle. That's it about it. And yeah, that's it. And expressing conditional logic as array operations. Okay, now let's see conditional. You have booleans here, right? So this is the x array, this is the y array, and this is a boolean array. Now first of all, I'm going to convert them into a, so that we can easily access each and everything as a single, like all these three will behave as a single entity if we use zip. That's the reason why I've used zip here. So I'm going to say a equals to zip of all these values, and for x, y, b in a. So in a we have we've zipped all these three arrays, and I'm going to print x. So you should get the elements of x 1.1, 1.2, 1.3. So see, that's what we got here. And let me just show you yeah, this one. See, if it is b, let me just clear this all. Yeah, so if b, what b contains is boolean array. So if true, print x, else print y. So first element is true. If true, print x, the output should be 1.1. If false, then it should print y. So the second element should be 2.2. If true, 1.3. So the output should be 1.1, 2.2, 1.3. True, that means 1.4. False, that means 2.5. Let's check that. Let's check what's the result. See, 1.1, 2.2, 1.3, 1.4, 2.5. Based on this, okay. So again, you can also use the np.where, so that you will get again the same result actually. So where boolean, this is our boolean array, and wherever this is true, you'll get x array, and if it is false, it is y array. So this order is important. First of all, you have to give a boolean 1, and if true, this value, else y. Okay, and yeah, that's the result. And I'm going to create a random array with 4 by 4, 4 rows and 4 columns. And as I already told you, when you compare it with some number, the resultant would be the boolean type. Okay, now you get wherever the value is greater than 0, you'll get true, and others will otherwise you'll get false. So np.where array greater than 0. So as I told you, where this function, the first this is a boolean array, and this says wherever it is greater than 0, make it 2, otherwise make it -2. Look, wherever it is true, it is 2, and wherever it is false, it is -2. That's it. And np.where array greater than 0, 2 comma array. Okay, see, if array is greater than 0, replace it with 2, and if array is less than 0, replace it with the same values of the array. Okay, see, initially array has -0.16. Again, whenever the array is less than 0, it should be the same as array. So same. And arrays where the value is greater than 0, they are converted to 2. Got it, right? So that is it for this tutorial, and in this tutorial we've learned about universal functions, array oriented programming, and expressing conditional logics as array operations. So that is it, guys. I'll see you in the next one.